Hello and welcome to this interview with Red Engineering. My name is Rebecca Uppendale and today I'm with Mohammed Royapoor, Head of R&D at Red Engineering. We will be discussing optimizing data center design in the age of AI. So what is optimization and how applicable is it to data center design?
In the language that my grandmother would understand, optimization is making something as effective as it can be, as good as it can be. But the mathematics of it could be really very convoluted. You need to have an objective. That's what you're trying to achieve. You have a set of variables. These are things that you can play around with, and you have constraints. So these are boundaries that you cannot violate. And then you optimize your system, and it's been a major part of quite a lot of sciences in business, in science, in engineering. We talk about optimization quite a lot, and they are applicable to data centers because data centers are very complex pieces of infrastructure. You've got your cooling, you've got your power systems, you've got your computational science and computational machinery. Increasingly, you have very, very complex processes taking place, machine learning and AI, and therefore the possibility of optimizing the global infrastructure is practically infinite.
And so what is the impact on AI on data center design, and how can this optimization help achieve a more sustainable data center design?
Well, AI has had a remarkable effect really on how we think about data centers and the layout, building form, the engineering that needs to support it. It's the densification, first and foremost. We are seeing densifications of IT racks that has never been seen before. And we have reached a level where there is a global consensus that we now have to migrate to liquid cooling because we've got so much power consumed in such a small space of time. So you will have a much more heavily engineered solution as your AI-ready data center that impacts not only your engineering design, but also your building form factor, your data hall form factor. We've had instances of looking at the height of a data center that was going to be AI ready. And from 4-meter floor to ceiling, we've now actually pushed it to 5.8 meter because of all of the additional engineering support that the racks need. When it comes to sort of the science of it, the stochasticity that there will be. The data center power consumption used to be quite predictable, but now with AI, we know that we're going to have quite a lot of noise as the machinery get ready to perform some AI duties, functions, whether it's training or inference, and then it goes back to sleep. So that stochasticity, that noise, is going to be quite new in the way we will see the power consumption of a data center. So I suppose to go back to your question, can we make these data centers more sustainable? Of course we can, and that's the beauty of optimization. In fact, it's its prime mission, prime guiding star, because you could be looking at your cooling system and optimizing it infinitely. In fact, you can look at your condenser circuit and optimize it infinitely. But the beauty of optimization, looking at it from a scientific point of view, is that holistic approach, that global approach of looking at all of your vectors, your power, your cooling, your mission critical equipment and the size of them, and trying to optimize them globally.
Off the back of that, can we reconcile AI deployment and net zero carbon ambition that most of the tech sector is working towards when it comes to data centers?
I think I am being candid that quite a lot of giants of tech sector have now publicly admitted that because of the deployment of AI and because of the huge amount of power the training needs, they might have to push back their net zero carbon targets. I don't want to name anybody, but people who would listen to this podcast would know immediately what these big boys of the business are. So yes, the reconciliation of AI development, the fact that it needs to move very quickly and wanting to be a net zero carbon sector is very, very difficult. So what we are really trying to advocate within the work that we're doing is just to put the best possible engine, use the optimization process to put the best possible engine on your site. Prime movers that are future ready, cooling solutions, for instance, that can be adapted for waterless heat rejection, if you can. Start with those net zero, net water prime movers, and then couple that with probably very flexible data center, data hall layouts. And then we cannot throw away our net zero carbon ambitions, Rebecca. We have to have them in place. And I suppose if it's going to be pushed further into the future, you still need to say, instead of 2030, I'm going to be net zero carbon by 2035, and then work back from that and decide at each stage how much you need to chip away at your operational carbon, how much you need to chip away at your water consumption in order to achieve that net zero carbon status by hopefully 2030, which most of our community is committed to, or 2035 if it needs to be. I suppose that's a powerful question, because it just needs to bring in some openness and some admission of difficulty and challenges that we have, but we shouldn't give up hope, because we've got this new toy that is going to hopefully bring in a golden age of prosperity, AI.
What are the most notable design evolutions that you've seen in anticipation of AI rollout?
I think densification, which we lightly touched on. I mean, we've got products now performing computational duty, which are at 40 kilowatts per rack. We've got NVIDIA 200, the X200 now being shipped around the world, which is at 120 kilowatt per rack. But we've got unannounced figures of 300 kilowatts and even beyond. So the densification is just off the chart, really. I think that's the major change, and I think with that comes the issue of liquid cooling, the fact that we now recognize it's not possible to cool your data center with air anymore. It has to be liquid cooled. And I think from a power management point of view, really, when you've got such heavily engineered solution with huge amount of power consumption, your power quality suddenly becomes a major guiding star, and all of the complexities that comes with power, particularly if you've got on-site generation, or you partly support your load with on-site generation. You've got your ramp up and ramp down. We said a bit earlier on that we're going to be far more stochastic. The load is going to be far more stochastic, far more noisy because of AI presence. Then you have a system that is behaving completely differently to the more benign constant loads of the past. And with that comes harmonics, with that comes load balancing issues on your distribution topology. With that comes the issue of high utilization. So there's a whole raft of design changes and considerations that start from the chip and the fact that the chip is now dissipating heat more like a nuclear power plant rather than the conventional chips, all the way to your racks and the engineering system. And the impact is not only on the engineering solutions, it's also really impacting the form factor of the data center. And how we lay the data centers out. Even more a reason to have a global, holistic view of how we design future-ready facilities, computational facilities.
And on the subject of the liquid cooling that you just mentioned, do we have all the knowledge, the products, and the certainty that we need to design liquid-cooled data centers of the future?
That's a very pertinent question. And I must tell you, I mean, I am running an R&D research and development team, and I sometimes get quite baffled with the whole raft of new technologies that are coming on the market. There's just so much announcements of new techniques, whether it's rear door heat exchangers or direct to chip or immersion cooling, whether it's single phase or two phase cooling systems. I think I think the landscape will continue to evolve, Rebecca. I think we have probably seen only the sort of the tip of the change we're going to see in the transition of technologies we need for liquid cooling. I mean, let's remember something. I mean, it's not a bad time actually to talk about it. All of the talk about AI and highly densified computational facilities of future, it hasn't left United States of America. It's still to land mostly in Europe, except for a couple of research facilities. We haven't had a major rollout. So by that, I'm trying to say that the technology will evolve. We have to address a lot of obstacles. We have hydrophobia, we're bringing a liquid to the racks. We have not done that before. We have additional complexity, operational complexity. We suddenly need to think about resilience, single points of failure, redundancies in very different ways that we didn't think about in the past. And I think the honest answer is no. Probably the best products that are going to enable us to have some of the best facilities of future are still on the research bench, but we're not far off from having them deployed in European and APAC data centers. That's some of the inquiries that we're dealing with actually at the moment within Red Engineering.
And with this kind of uncertainty within the space here, how do you factor in future uncertainties in the design optimization process?
I think it's inevitable. I think the reality of computational science is that it has moved much faster than any other science. It's absolutely remarkable what it has done over the past 20 years and its transformational effect on human existence, really. I think we need to look at the best practice. There is a whole raft of scientific disciplines where you have uncertainty modeled within economics, within drug development, within energy modeling, future energy modeling, where you look at a number of scenarios about how much, for instance, penetration, nuclear or renewable or wind turbines or conventional power plants would have. And you look at those scenarios and you model them. But to come back to the data center sector, and I borrow from some of the conversations I've had with leading designers within Red, with some of our clients. The truth is, you have to sit down and map what you're trying to create very, very carefully to stay relevant in 2030 or 2035. Or if you have a facility that you want to maintain operational until 2040. We had one project in APAC region where the brief was given to us and we completely rewrote the brief. It went back to the client and it came back because we suddenly, when we sat down to say that, not all of the AI facilities need to have superlative capabilities. Some of the actually basic AI, at the top end, science is trying to replace the human, to have a virtual worker. Mm-hmm. But most of the AI applications, you would find that people are looking for translation, for search engine duties, for transcription of meetings as we get, for instance, on Teams, summation of documentations. And with those, there's a whole raft of actually new chips that are also emerging on the market that are not as power dense as, for instance, NVIDIA products. They're not as expensive. You don't have to wait for them for as long. And then when you have that sort of holistic approach, what's the chip you want to deploy? Then you take it to the server arrangement that needs to support that computational duty. You translate that to the data hall form, and then all of the engineering that needs to support it. Then you could really take that uncertainty, develop it into a couple of scenarios that you want to look at, and then it guides you on where you want to be. I mean, perhaps not a bad time to talk about conventional compute, the more sort of not AI related, but standard compute duties. It's actually going also to double in the run up to 2030. I think because of the sheer magnitude of what you need to do in order to support AI, conventional compute has become the ugly duckling in a way. It doesn't get any attention, whereas it's also going to double in the run up to 2030. And I think you have to develop those scenarios and those briefs carefully with your client to say, do you really want a super duper facility that can perform NVIDIA duties, next generation NVIDIA duties in its entirety? Or do you want a facility that is a bit more holistic? It can enable standard compute to function in some of your data spaces, and then probably you have a space for AI-ready, top-tier AI-ready compute, or even quantum computers. So those scenarios can be, they need to come out of a fairly heavy, honest initial dialogue with the client or with the operator that is looking to generate the design of a retrofitted or a new facility.
With optimization specifically, that always requires a boundary to the problem. So if we're talking about optimization, do you stop at the data hall, the campus, or even the wider energy ecosystem?
I'm very fond of Dame Dawn Child, the CEO of Pure Data Center. And I heard her saying when we were building 3 megawatt data centers, it was okay to stay under the radar. But now that we're building 100 megawatt and 200 megawatt data centers, we really need to look at ourselves as a part of the wider ecosystem. And I think that should be really our guiding star. I think we have reached such a remarkable magnitude, both collectively as the entire industry in aggregation as a function of the world energy demand, but also individually, we've got facilities that are consuming as much power as a city. We've got, 600 megawatt, 700 megawatt data centers being talked about. And I think what that really from an ethical point of view, and as engineers, we have very strong ethical responsibilities that we need to discharge. We need to take the boundary of how to think about designing the next generation of data centers much beyond the campus itself and the data hall itself. We need to think of ourselves as a part of the ecosystem, as a part of the community. We need to think about heat export. We need to think about heat rejection. We need to think about helping the grid with stability functions. We need to be much more of an active citizen in shaping the future of energy systems, but also neighborhoods that benefit enormously from hosting a data center. So I think the honest answer for me to your question is the optimization really needs to start from the entire ecosystem and then trickle down to exactly what we're trying to achieve in terms of computational duty and meet all of those objectives.
Fantastic. Would you say that for the audiences watching this, that would be the key takeaway from this interview?
Excitement. I think it's a privilege to be a part of a sector that has changed the shape of humanity, the way we communicate with each other. I was 16 when I touched a computer for the first time, but now you have a farmer in sub-Saharan Africa being able to use AI to optimize how to reduce post-harvest waste of its crops. That is a remarkable achievement for humanity, and it's for everybody. It's not only for the rich. We are helping humanity to be a better family, but also the huge burden of responsibility, perhaps, Rebecca, that we have as designers, because these are giant facilities, and they have an enormous amount of resources that need to support them, and we have to do it as intelligently and as compassionately as we can. But exciting times ahead.